Assalamualaikum and greetings. We are Group 3 in Project Linux System Management and Network Services. My name is Muhammad Fahad Koyim bin Muhammad Fairuz, and I will be demonstrate and testing about DHCP services and NTP services.
Hi, my name is Azan Kamili bin Abdul Jabbar. I will present DNS and test about the DNS.
Hi, Assalamualaikum. My name is Adrian Aziz bin Muhammad Nizam, and I will presenting and demonstrating about web server.
Hi, my name is Nurul Hurin binti Muhammad Azri. I took part in the SSH and SFTP network services.
So first, we need to type format IPA to check whether the client is on the range or not. As we see, in the client, its host tree is set to internal level, which is it will connect to the server. Like we see here, the IP for internal is 192.168.13.123. Next, let's see the range of DHCP IP from the server. So just start sudo nano slash DHCP slash DHCP. So as we see here, the range for DHCP services is between 192.168.13.200 to 192.168.13.254. The first security policies that I use is DHCP MAC address binding, which is this policy make sure that only assigned over the client can receive a specific and specific IP from the server. So first, let's check the MAC address from the client, which is IP lecture repository. So this is the MAC address for client. Then let's check the configuration. So we use sudo cat DHCP dhcp.conf. So this is the configuration for security policies. So that's it. Let's check. Let's try release and request again IP from client to server. So this so we release, then request again. So you see here, the request IP, we request a new IP is 192.168.13.160. So let's check IPA back. So you see this is the new IP address that we just request from the server. The second security policies that I use is DHCP log for monitoring, which is responsible to check what activity the about DHCP just do. So the command to test it is sudo tail /raw/raw/dhcp.log. So as we see here, there is activity from release and request IP from client that we just do for the first security policies. For testing, client we use cron YC sources. If the star symbol pop up, it means the client is active to sync its time with server. To make sure that the NTP service is 100% synchronized with server, we use the NTP stack. And the IP gateway for client, it should be shown. As we see here, the gateway is shown 192.168.13.10, which is server IP. I use access control list as security policies. For testing, first thing first, we need to make sure the IP that we get is between range on the DHCP. As we see here, this client use 192.168.30.123 and also .160. So now, another testing that we need to use is cron YC sources. So make sure the star symbol is pop up to make sure the means that this client is active to synchronize time with server. Then we use command NTP stack to make sure that the synchronize is successful. As we see, we have server IP or the gateway IP from the client. Now for security policies on NTP service, I use rate limiting. To test these policies, I will do DDoS simulation, which is I will try float loss of packet to this service. So this is the command. Now we enter, and then on server, I use sudo cron-yc clients. The drop level should be increased to 1. Sorry, cron-yc HPC, the drops just increased to 5, which is loss of packet just flooded to the service, and also the policies just track and remove all the packets that are excessive. In conclusion, the successful implementation of DHCP and NTP service spread and secured, automated, and also a synchronized network environment. So by DCP with MAC binding to prevent the unauthorized access, and also the DCP log monitoring to track and check what happened exactly or activity on the server, and also for the NTP to make sure the time is synchronized between server and also client. In addition of security policies for DDoS and also rate limiting to check whether the server can track and remove the excessive packet.
Thank you for the explanation. Now we're gonna move part to the DNS, which my part are gonna explain and show the demo and test if the DNS working fine or not. First, what we're gonna do, we're gonna move to our DNS server. You can see over here, we're running a sudo systemcts status name, which is running then Berkeley Internet Name Domain, or his short name is bind. That's we need to install. That's commonly used for setup DNS for the Linux. As you can see here, is active, running perfectly fine. And we try to check the configuration, and as we can see, the zone for the cloud net is also okay. We also try to use D for our cloud net, because D is for use to check is working fine or not in the system base for the Linux to communicate. And we can see over here in the server, it says status has no error, and most likely everything that we see on the D will be same both on Linux and the server, on the Linux server and the client. We also try the FTP, and as we can see here is no error, everything is look perfectly fine. Now we're gonna move to our client. First, we try to ping to our server IP. As you can see here, the connection is perfectly fine, have no error. We try to do the dig on our server CloudNet. As you can see over here, everything is working fine, status has no error, and everything is working good. Same as the FTP for the CloudNet. Is everything is working good and have no error. In the summary, in the DNS server is configured correctly. The zone CloudNet resolves successful, and the client communicate with the server this completely by DNS testing demo. So both client and server DNS can communicate fine and have no error. The test has successfully, and the DNS is working fine and working fine. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adri, and I will demonstrate on how to set up and test an Apache web server on Fedora Linux. I'll show each step directly in the terminal. Okay. Open your terminal on the server. So you enter this command. This updates Fedora with latest packages, so we need to wait. Just press no, because I already pressed it. Okay. Next, this installed and the Apache server. So as you can see, I already installed it. Okay, so this command will start Apache and enable it to run in a boot. Here we can see the Apache is active and running. Now we will configure firewall. So HTTP allow HTTP traffic to the firewall. Then to the web page creation. You see it already went into the direct. So you install Nano. So the Nano editor is already installed. We're gonna go into the Nano. You need to set the file. So now we're gonna verify if the file is here. We see an index.html is saved here. So it was a successful. Now we're gonna set permission. Okay. This ensure Apache can read the file. So now we will be testing the server. We enter the custom page that we already made. You can see this shows the default Apache test page. For the custom page, you can also enter server IP and it will show hello from group. Okay, so now we're gonna do the testing on client PC. The first step is to set server IP. As you can see here, the IP is 192 and 168.100 and 2. So test first in terminal, then we're gonna go to web. We're gonna pick the IP server. You can see the ping was successful. Now we're gonna try to reach the server using curl. You can see the client successfully loads the server web page. So now we open the custom server. You see, we are in client and I can also reach the server by using a client PC. So in summary, I demonstrate how to install, configure and test Apache on Fedora. The server is running, serving a custom page and accessible from a client. Please confirm the web server setup is successful. Thank you so much. That's all from me.
Hi, my name is Nurul binti Wawa Azri. In this project, I took part in configuring and securing our SSH and SFTP network services. Let's start with our server-side check. I will verify our static network parameters by looking at interface EMP0S3. As you can see over here, the server is using our assigned static IP address of 192.168. Next, let's verify our active system service status. The OpenSSH daemon is active and running, meaning our custom firewall policies and configuration changes are fully live. Now, let's move to our client machine to test our active security policies. First, I will verify network connectivity to the server. The ping succeeds with 0 packet loss. Next, let's prove that the standard authorized user can log in over SSH. Hit C to log back out. The regular login works perfectly. Now, let's test our next security policy, blocking the root administrator from connecting directly over the network. The server immediately rejects the login with a permission denied error. Running Huami proves we remain trapped on our local machine as the Fedora user, confirming root login is blocked. Finally, let's test our SFTP restrictions. We will first try to open a standard command terminal using team profile member 1. The server blocks the command terminal instantly, stating this service allows SFTP connections only. Now, let's access the server using the proper secure file transfer client. We are successfully logged into SFTP. However, running pwd outputs our directory simply as / and ls only lets us see our assigned uploads folder. The user is completely trapped inside a secure chroot jail and cannot browse internal system files. This completes the demonstration, proving our security controls work perfectly. In conclusion, our tests show that both systems are fully safe. For SSH, standard users can log in easily, but the root admin is completely blocked from the outside. For SFTP, users cannot use the command line at all. They are locked inside a safe folder and can only see their own files. These settings keep our whole server safe and secure. Thank you.
On behalf of Group 3, we would like to thank you for watching our demonstration and testing for each services. We appreciate your time and attention. Thank you and have a great day.